Welcome to the second part of calculations involving the moles. So let's get started. Now, there are other calculations involving the moles that you may be asked to do, and those involve solutions rather than solids. We can also look at mole calculations involving stuff that is dissolved in liquids, most likely in water, because this is the most obvious solvent that you have to know about for your GCSE chemistry, but it doesn't have to be the only one. So the concentration of a solution is measured in moles per decimeter cubed. So how many moles there is in a decimeter cube, and decimeter cube is the same as 1 liter. Okay, and it's also the same as 1000 centimeters cubed. So the formula triangle here looks as follows. At the top we've got the number of moles, at the bottom we have concentration and volume in decimeters cube. Remember, the standard unit for volume is in decimeters cube. So if in a question you are being given the volume in centimeters cube, you will very likely have to convert it into decimeters cube unless you're told otherwise. So the actual equation looks as follows. Number of moles equals concentration times volume in decimeters cube. Or you could say that number of moles equals concentration times volume, but you have to divide it by 1000 if the volume was given to you in centimeters cube. Again, to convert it into the decimeters cube, because that's the standard unit that you want to be using for your volume. And if we rearrange that equation to calculate the concentration, it's number of moles divided by volume. Again, I'm going to stress it one more time, in decimeters cube. So let's have a look at a worked example. Calculate the number of moles in 200 centimeters cube of 0.5 mole per decimeter cube sodium hydroxide solution. So you would do this in a quite straightforward fashion. Using the triangle, you first have to work out, okay, what am I trying to calculate here? So the question is, calculate the number of moles. Okay, so if we take away number of moles from our formula triangle, what we can see is that to calculate it, we need to multiply the concentration by the volume. And you refer back to the question, do we know what the volume is? Yes, we do, it's 200. Do we know what the concentration is? Yes, we do. It's 0.5. The trick here, however, is to remember that since the volume was given to us in centimeters cube, rather than decimeters cube, we have to divide it by 1000. So when we substitute the numbers, it's as follows: 0.5 times 200, and then we divide whatever we get by 1000, which means 0.1 mole. So what I would like you to try and do now is try the two following examples on your own. Calculate the number of moles in 50 centimeters cube of 0.1 mole per liter zinc sulfate solution. And the second one, calculate the number of moles in 0.2 decimeters cube of 2 mole per decimeter cube sodium hydroxide solution. So you can pause the video now and just give these two examples a go. So I'm just going to assume that you have done it now. So for the first example, the answer would be 0.0005 moles. Now, there are two things that you need to bear in mind with this example. Firstly, we had to divide by 1000 because, again, the volume was given to us in centimeters cube. And secondly, the unit for concentration was given as mole per liter, which, although it may seem a little bit confusing, remember that decimeters cube and a liter is the same thing. Okay, and then the second example, the answer is 0.4 moles. That one is rather straightforward because the volume was given to us in decimeters cube. The concentration is just mole per decimeter cube, so nothing to confuse us here. We just multiply the two together and we get an answer of 0.4 moles. So what we'll try doing now is we'll look at examples of questions where both of these equations have to be used to get an answer. So we'll look at example number 1, which is calculate the mass required to prepare 200 centimeters cube of 0.1 mole per decimeter cube sodium hydroxide solution, and the sodium hydroxide solution is NaOH, 1 atom of sodium, 1 atom of oxygen, 1 atom of hydrogen. So step 1, calculate the number of moles of sodium hydroxide in 200 centimeters cube of 0.1 mole per decimeter cube solution, and for that we're going to have to use our formula triangle for the solutions. So what we're trying to calculate here is number of moles. So number of moles equals concentration times volume, and it will be divided by 1000 when it is not in decimeters cube. So in this case, our volume is in centimeters cube, 200, so we have to divide the answer by 1000. So when we substitute the numbers, the answer should be 0.02 moles. Now, the question doesn't actually ask you to calculate the number of moles. Instead, it asks you to calculate the mass. So if you want to know the mass, you have to calculate it using the knowledge that you gained in step 1 of how many moles, and using the knowledge that you can gain from periodic table about relative atomic masses of the 3 elements that we have, and then calculate the formula mass. So NaOH, the formula mass equals 40. Again, pretty straightforward step. Look up in the periodic table, add up all the atoms, you get the answer of 40 in this case. And then you want to calculate the mass to finally get our answer. And again, for this step, we're using our second formula of mass equals number of moles multiplied by the formula mass. When we substitute the numbers, the answer should be 0.8 grams. So calculations for you to try. Calculate the mass of zinc sulfate in 500 centimeters cube of 0.2 mole per decimeter cube ZnSO4, zinc sulfate. Just give it a go. So, considering that you have done it, the answer should be 16.15 grams. So again, first you have to work out how many moles there are using our equation from step 1, the solution equation, and the answer would be 0.1 mole. And then using the second equation, using the masses, you do 0.1 times 161.5 to get the answer of 16.15 grams. So we're going to have a look at the second worked example, but this time, rather than for the mass, I'm going to ask you for the concentration. So calculate the concentration of a solution that contains 7.45 grams of potassium chloride in 250 centimeters cube of solution. So what you'll notice about this question is that when I ask you for the concentration, our steps are going to flip. So I'll just show it to you now. Instead of starting with using our solutions equation, we actually start by using our mass equation. So we'll start by calculating the number of moles here, knowing that we've got 7.45 grams. So how many moles of potassium chloride are there in 7.45 grams? So again, you will look up your periodic table to find out your potassium and your chlorine, you add them up together and you know the formula mass of the potassium chloride, and then you will divide the mass by the formula mass to, in this case, get an answer of 0.1. So we have 0.1 mole. And then in step 2, we're going back to our solutions equation to calculate the concentration. So concentration is number of moles divided by volume. So we know from step 1 that number of moles is 0.1, and we know from the question that volume is 250 centimeters cube. So what you can do in this step is either divide by 250, then multiply by 1000, but rather than doing that, it's much easier to just convert your centimeters cube to decimeters cube before you substitute the numbers. So a 250 centimeters cubed becomes 0.25 decimeters cubed. And if you do this calculation, the answer would be 0.4 moles per decimeter cube. So what I'd like you to do is to try one example on your own. Calculate the concentration of a solution that contains 5.85 grams of sodium chloride in 200 centimeters cubed of solution. So pause the video and give it a go. Okay, so I'm going to assume that you have done it by now. So again, you just use the steps. Firstly, volume equals 200 divided by 1000. Remember, we want decimeters cubed. So with questions like that, especially when you're using a combined method, you may just want to convert that volume straight away into decimeters. So it's going to be 0.2 decimeters cubed rather than 200 centimeters cubed. And then you calculate your number of moles. So again, we're going back to our equation for the mass in 5.85 grams of sodium chloride. So what we have to do in this step is to work out what is the formula mass of the sodium chloride. Again, straightforward. Look it up in periodic table. What is the relative atomic mass of sodium and of chlorine? And if you add them up together, you see that the answer is 58.5. So as you can see, these numbers have been chosen for a reason, because if we divide 5.85 by 58.5, it gives us a really nice answer of 0.1 mole. So then you do the second step where you calculate the concentration, and our concentration is 0.1 divided by 0.2. So what are these numbers again? Well, 0.1 is our number of moles and 0.2 is our volume. So the concentration is actually 0.5 moles per decimeters cubed. So that's where I think we're going to end this lesson today. Hopefully you have learned something about calculations involving moles, and I will see you soon in my next video. Bye.